one, what are we going to try? What kind of solution are we going to try? Y equals, and say we are treating our independent variable as t. Okay, so in this case we are trying what? E to the mt as a solution. All right, everybody clear? Everybody fine on this? And now when we try that, then Fad, you were not here last time, but I think you can help us still, right? Okay, so if I try that, what will happen? I'm going to look at the solutions of which equation? M squared minus m, yeah, keep going, minus 2, thanks Jocelyn, right? Is that coming back? Huh? Use K, or some people use S, alright? So people use different notations, it's the same thing, right? Everybody fine? Okay, so if I solve this, then if I factor this, I meant, so what will happen then? We have this factors like that, right? Everybody good? And that means m equals -2 and m equals -1 on the are the solutions. 2. Thank you. Good attention. I am really proud of us. Thank you. Yeah, we are right here. Thank you so much. Good. So what happens now is that, so what are the proposed solutions here? E to the 2t and e to the -t, right? Everybody fine on this? Okay, good. All right. So check that. I mean, you may check it that they are solutions, right? Everybody clear on this? Okay, Geo, makes sense? Yeah, good. How would we check it? Just substitute that in the differential equations and you will see that you are going to get what? You are going to get an identity, right, Kareem? Good. Okay. Everybody fine? Go ahead, please, Young. Say that once again. Oh, okay. We did this. M minus 2 has, could be 0, which gives me what? How did I? Oh, I factored this expression, right? Okay. All right. Check means, okay, so check will be, like, see here, if y is e to the 2t, right? That means what? Y prime is 2e to the 2t, right? Am I clear?
So we just take the derivative of the first derivative, second derivative.
Exactly, and then right,
Oh, okay.
and then just go ahead and substitute. All right. Am I clear? Right?
Yeah.
Okay. So Salim, is that your question, or? Yes. So when you substitute, these quantities in here, it will be identity. So I am allowed to proceed, right, Salim? Thank you, sir. Okay. Yes. What happened? What's so amusing in here?
So you're gonna have.
I don't know. Why am I not Why am I not substituting it? Go ahead. Yes. Ask me a question.
Well, I was just trying to figure out, and so you're gonna have 4 e to the.
Okay, and you are rightly trying to figure it out, because I have no idea why I just, instead of doing it, I just try to just kind of get my way out of here, right? And this is this, right?
Yeah.
Are we good? minus 2 times y, and who is y, right? And this equals what? 0, right? Everybody happy?
And from there,
So we have that y equals e to the 2t is a solution, right? Am I clear? And then what happens? And another solution is what? E to the negative t. If we want, we can number them, that this is solution number 1, and then this is solution number 2, right? Is, we may say, another solution, right? Geo. Makes sense? Works very good, Daniel. Makes sense, sir? Okay, is another solution. Now notice this, that y1 and y2 are linearly independent. Okay, linearly independent, and that's what we wanted. We had a second order differential equation. We wanted two linearly independent solutions, and we got it, right? Okay, so if you would like to write a general solution, then how you can write a general solution? Just write a linear combination of these guys, right? That is c1 e to the 2t plus what? c2 e to the who? Negative t, right?
that does work confused with the input and with that answer.
Is that unconfused now or no?
No, not anymore. Yeah,
It's
no,
not confusing anymore, right?
I was trying to
Everybody?
figure out.
Exactly. So I have a linear equation with constant coefficients, right? Here. So, and it's, so we are again going to try e to the mt, right? To obtain what? To obtain two linearly independent solutions. This is just what we are doing is this, that we are, we have like a wise guess here, right? Okay, and then using this, we might be able to arrive at a solution, right? Alexis, makes sense? Okay, good. All right. So Jose, what equation shall we get? Help us, sir. From this one, I'll get the way you go, m square, right? Plus 2m, very nice, plus 2 equals 0, right? And we cannot factor it with integers, right? And when you can't, then what? Try factoring it with like integers. We can't. So, but yeah, Gio, think that we tried and we gave up, right? Okay. So in that case, what shall we use, Raphael? We might use. Let's try the quadratic formula, right? So -2 plus minus, right? Square root of, how much is 2 square? That's a 4, right? 4 minus 8. Okay, very nice. So everybody fine on this so far, right? Brenda, is that good? Okay. Yes, that will be -4. You are going faster than I can write. So give me a second. -4, right? So here, what do we get then? Very good, going much faster than I'm able to write, right? So anyways, but that's very encouraging, right? So here oops, sorry about that. -1, okay, over 2, and that is, everybody fine? So what are our two solutions? Faisal or Salim, you help? What are our two solutions in here? One will be e to the what?
E to the negative.
Go ahead. Negative. So let me first.
Negative 1 minus.
1 minus it and 1 plus it, right? So here is t, so that becomes what? E to the negative t plus what? it, right? Everybody. Say that again. Go ahead, Alexander. I is square root of negative 1, remember? That complex number. So right here, see, when you have a square root of negative 4, it becomes a square root of 4 times the square root of negative 1. The square root of 4, the principal one is 2, right? And the square root of negative 1, we write it as I, right? Answer the question? Okay, let's explore that, all right? Okay, very good question, okay? And the other one is what? I have a negative sign in the other one. Thank you, very good question. So here we got this, and we got a lot on our plate now, right? Everybody fine? So we got these two things, right? Now, how many of you remember the transcript from the last time? Remember we were visiting our favorite Maclaurin series and Taylor series and all that? Huh? Right? So when we expanded cosine, sine, and exponential using those theorems, right? What had we gotten at the end? If I have, very good, thank you. Who was there? Was it Salim? Daniel, thank you, Daniel. Thank you so much. So cosine of theta plus I sine theta. Very nice. Thank you. Say that again, Jose. Never mind. I will not mind. Okay. Everybody fine? Okay. Is everybody good here?
No.
This is a formula that we derived last time. This is called the Euler's formula, and I'm just paying tribute to big mathematicians, and it was a consequence of who? Maclaurin and Taylor, right? Go.
I is imaginary, right?
I is imaginary, right? Exactly. Yeah, so don't get too anxious. We get sometimes real from our imaginations, don't we? Right? Okay. Okay. So you want real solutions? Let's see if our imaginations help us arrive at real solutions. All right. Okay. I'm just being a little informal here, but okay. Very good question. Okay. Brandon, question, sir? No. Okay. So, anyways, if you look at this and you look at this, okay, then what do they give us? The two together. They give us that we have y equals, I could write what do you call C1 and C2, but I'm writing it like this if you don't mind. That's general solution, and Alexander doesn't like i's in there. Let's try to get rid of those guys, okay? All right, okay, to be in our real realm. Everybody fine so far, right? Okay, Jocelyn, makes sense? Good. So we are just going to go ahead and exploit this equation, okay? So what do? We got here, and now it will simply be algebra, right? Okay, so let's do some algebra. Negative t, then what? E to the, what's that? it. Everybody clear? And then we can change this here. The only thing that will be, this will become negative it. Everybody fine? Good. All right. Does anything factor in here? That just to make life easier? Negative t, right? Is it factoring out here or no? Help? Okay. So when that factors, Then what do we have here? You don't mind if I put this kind of bracket here, because there will be several brackets coming in. It'll be good to distinguish. Okay, everybody good so far, right? Okay, go ahead.
After Euler's formula,
Euler's formula, yes.
how you come up with the equation y equal to a.
Oh, I did this. See, these are linearly independent solutions, right?
That's why you write a letter.
Exactly. I wrote them as a as a linear combinations of these, and now we are working with this to see if it will give any real solutions to us. All right. Okay. Good. Thank you. So now after this we can use the Euler's formula, right? So who is this here? Help. Cosine of t plus I sine t. Everybody clear? And who this will become then? Cosine of negative t, right? It's the same, I know. Very good. Thank you. I'm forgetting my trigonometry, but you remember it, and that's nice. Okay. Everybody fine? Thank you, Jose. Very good, sir. Okay. So then we have what? So as we said, as Jose recalled for us, this is simply cosine of t, and sine of negative t would be negative sine t, right? Everybody fine? Good. Is that good for all of us? Right? Okay. Oh, thank you. Thank you. Yes, go ahead, Alexander. What happened? Did I screw up something else? No? No? It's okay? Oh, okay. I don't know why I wrote that as minus b. I did, right? I have no idea. Okay. Everybody good? Thank you. So what we have then is the following. Okay. All right. I'm trying to do it very fast, so watch me very, very carefully. All right. So here we have what? A plus b, then what? Cosine t, right? Am I clear? Then we will have a minus b times I sine of t. Is everybody clear on this? Everybody fine? Go ahead. Oh no, it's not. It's like this. We just rearranged it, and if I made a mistake, we have Alexander watching me. So, okay, so we'll fix it, right? Thank you. So, in here, if you look at this whole thing, okay, and good news is that we won't have to write it like this again and again. All right. So see, this is. Let me just bring this factor over here, right? And bring this over here, right? Okay. So the two, so we have this written in this form. All right, everybody fine? And you can check if you want. All right, that if I look at these two guys, indeed, I'll scroll up. You mean like this, or okay, sure. Yeah, so that you can see, right? Yeah, exactly. Thank you. Okay, and of just check. I mean, I can check it for you. All right. So you can check that these are solutions of this guy here. All right. Am I making sense? Right. And of course, see, these two are, and they are real valued functions, and these solutions that you had obtained earlier, which were like non-real complex valued functions, they can be written as linear combinations of these. So nothing is being violated, right? Alexis, am I making sense?
Yes. We got rid of the I because in the sign one, just because we had only solved a real solution.
Yeah, we were looking for real solutions, right? And then the news is good that these two real valued functions, okay, that we pulled out of this, they are solutions of that, right? And you can check it out, all right?
Minus t sine t still real if it's sine
Right, but I don't have any I here, see? Do I?
no, you have I
I have I there, but let's see this here, that we didn't even look at it, all right? And say we are starting here, okay, Alexander? Okay, ignore whatever we said first, all right? So say I have this differential equation, okay? And then suddenly Jose tells me that these two are solutions of this, right? I can check that yes, they are solutions of this equation, right? Okay, I is not even in the picture. Makes sense? All right. And of course, one moment, Salim. And we are not contradicting our earlier calculation because when you had e to the negative 1 minus it, okay, that was a linear combination of these two guys, right? Okay. So that is fine as well. Okay. All right. Go ahead, Salim, sir.
Before I have a similar question to this one. You have to go through all the steps.
No, 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 no.
Give us this.
I won't give you the solution, but you no, you can do this. I know. Okay, just a second. Let's write this for Faisal. Okay, that is no. I mean, sorry, I didn't mean that. That was a rude answer on my part. I'm sorry. Okay. Okay. Excuse me. Sorry. Okay. See. So here. See, if you get alpha plus minus beta I as the roots of that, you call it auxiliary equation, but let's not inundate ourselves with like vocabulary. Okay. So if you get this as solution of the equation that you got, right? Then what you can deduce is this, and on the test you can directly use it, all right? So that is if my independent variable is t, right? So one solution is who? Cosine this times cosine beta t, and the other one is who? And you don't have to show me all that story, okay? Am I clear? Okay, so you can recognize right from there that these two are linearly independent solutions of that differential equation, right? And that makes life very easy. That another way of writing general solution is what? Y equals, I may say C1, right? This plus what? C2, and then we get that. Everybody fine? Everybody fine on this? Good.